And the next one, the BiFunction.
Man, you're bringing the tough ones to the challenge.
We can also check here if you want to. So the BiFunction interface returns a type
Right.
and receives two parameters.
Right.
Any type. We can pass here, for example, a
Okay.
string. We can pass,
So
I don't
yeah.
know, a
Okay.
string builder here. We can return
Right.
an object.
Okay. Right. That's actually, so that helps. Okay. So how about open brackets, x comma y arrow? You return x plus y.
It works, yeah. So just an additional here, if we want to use more lines in a Lambda, we can do that as well. It's just a difference in the syntax.
Yeah.
But it's the same.
Yeah.
We
Yeah.
don't need that.
Yeah. Thank you for the pointer.
Okay, you're welcome. Now the method reference.
Considering that we need two parameters and a return of an object that could be also a string, we can try like a string, uppercase string, right? Like a string object, column compare to. I don't know if it's work, but
it works.
Yeah, because the string would need an argument compared to need the second one, and they will return a string. So
exactly, it matches exactly what we need. Because as you said before, we need an instance. So we've got to pass a string here, and the compare to method receives another parameter. So we would be passing two parameters and returning an int, but an int is an object. So, I mean, it would be boxed to a wrapper integer, and it would be returned as an object. So it's completely fine.
Unary operator. I think this unary operator it's get a string and return a string. Is it right?
Yeah, so the unary operator is very similar to the function. So we can see here that the unary operator extends a function, but the difference of the unary operator is that it has to receive the same type that is being returned. So that's the main difference, because it's extending here the function, but we are passing just one type here.
Okay.
So the types have to be the same, and that's the difference basically.
Okay, so we can use on the same way as we used it before. That would be, let's put Homer instead of Jedi. Homer, and then Homer concat Marge.
Oh, nice. Yeah, that works.
You can copy and paste. No worry about this, Fahad. I just changed the variables because the structure is exactly the same.
So this one basically is taking the integer.
Yeah.
So okay.
Oh, now I see. You put an integer just to make things slightly different.
Let's make this one different as well.
Oh, damn.
So let's see. Integer. So can we write integer colon value of?
Yes, we can.
I think it's happening the outboxing. Yeah.
It is, yeah.
Yeah, it is outboxing it.
I was thinking about the int value, but it would be on the opposite way.
I think for that matter, even the parse, even the parse value would work in that case, because if value of works. Yeah, it is basically doing outboxing the int back to integer.
We should be receiving two parameters, right? It's because it's a static. Yeah.
Yeah.
So we don't need an instance here. So yeah, we receive just one parameter. Yeah, that makes total sense. Okay, that's perfect. And what about the binary operator?
Now it's your turn again, Fahad. I will get the last one. I'm worried about the last one.
I can show you if that helps, what happens in the binary operator.
Okay.
So the binary operator basically extends the BiFunction interface. So it's basically the same. The only difference is that the binary operator operates with just one type. This means that it receives two parameters with the same type and returns one value with the same type we defined here. So as you can see, it extends BiFunction, and then the same type will be replaced here. And then the binary operator will use the same function with just one type. So we could translate this method as returns t, receives t, and receives another t that is just one type that we defined in our generics here.
Okay. But then you are having only one parameter to be passed, right? Which is double.
No, actually, it receives one type, but
you receive 2 parameters.
but
but
receives okay, it receives like 2.
so even though we pass just one type, so that type is going to be passed here, that is t, but
Okay.
you can realize that those methods here, this method is static, and this other method is static, so it's not our functional method. Our functional method is here, actually, in our BiFunction.
Right.
And the binary operator extends the BiFunction passing the type that we passed there. So it would be double here. We could translate this to double.
So okay, so then in that case, can I basically reiterate the same thing what I said for the BiFunction, which would be x comma y, and it returns. So I would like to go with a verbose. So curly brackets return x plus y. Simple and easy, I guess.
Yeah, this one I was guessing on the same way. Yeah.
Yeah, that will work for any kind of type. We could pass object. Yeah, it works with most of the types. Congratulations, that's it.
I think I think if you put a plus with a empty string, it wouldn't work with double, right? Because you're returning a string.
Yeah, because then it doesn't know what to do with the string.
Following one, I would try to put double colon compare.
We might want to wrap around with the double dot value of or something like that to the compare or the compare to method reference, because we want to return a double, right? And since compare method is returning an int.
Okay, yeah, okay, makes sense. Yeah, let's try. Yeah. Oh, oh damn. Why? Is it static? I don't know if it is static.
It is static, yeah. So
that's why
it won't work.
Yeah, my kind of tricking the process would be pour beer processor colon apply just to try to
beer processor.
Yeah.
Pure BI beer processor. The first one, the first binary operator.
And then colon apply.
Or you can probably do dot apply.
I don't know, because it's a method reference, so we need to put the colon.
Okay, that works, but it's not fair. So do you want to check the methods from the double?
You can use sum, I guess, which basically takes in like 2 doubles and returns a double.
Okay, how can we do that?
Oh, max? I don't know. I didn't know that.
You can use max, min, sum. I think you can use both.
Okay. How can? What is the version that you are using? The Java version?
Java 13.
Oh, maybe that's the problem, because I'm using the Java docs of Java 7.
Oh,
Let me see. I said, well, what? I'm with this open. Let me search here. So, okay, now I'm the Java 13.
So you can do like double colon max.
Yeah, sure, we can use it as one, Fahad. Yeah, max. Double colon max for sure.
So what if this method was an instance method? Could we use the max method yet?
I think Rafa is asking if we can use the instance methods rather than static methods. Is that
exactly? Let's put this method here. Can we use this method here?
Sure.
Okay, but can we use like that, putting just the class here?
No, I think we'll have to do something like new something. So match the lambda challenger colon new, and then
that's it. Perfect.
Yeah, that is what I was guessing. Yeah, that you have an instance that you can call the same. Yeah,
exactly.
Okay,
that's perfect. I think you really mastered the topic. Okay, congratulations, guys. You did great today.
Thank you, man. And congrats, Fahad.
Congratulations, Rodrigo, to you as well. Yeah. We learned something new, and we learned something from each other. So that's the best way how you can learn, I guess.
Yeah, exactly. Very good team.
And thank you, Rafa, for such a lovely mind-boggling challenges.
Thank you. Yeah, it's amazing to understand how that works, because when we are working with Java, if we know exactly how to match a method reference or lambdas, we can use this power all the time. Otherwise, if we don't know exactly, how can I match this method reference? Why it's not working? It limits our code, because if we don't know how to match them, we take much longer. We usually use more code than necessary, and it's amazing the power that method references allow us to implement in our systems.
Yeah.
Very good one.
Cool.
Okay, guys. So thank you very much for participating and helping out the challengers to be amazing. Okay, guys. So you saw a different type of challenger. So this one was a cooperative mode challenger, and you could respond to each of the functional interface of how you can use Lambda or method reference and how to make a method reference match on each functional interface. You learned also the most important functional interfaces from Java. If you know those interfaces, don't worry about the others. I mean, you can still learn the others, but chances are that you won't be using the others functional interfaces. So if you know those functional interfaces, you know around 99% of what you need about functional interfaces. Okay, so that was maybe a long video, but you could see the whole picture of the most important functional interfaces from Java. Okay, and one amazing way to really absorb Java concepts is by trying the code by yourself, running your tests, changing the code, and just checking whether it works or not. And then I'm offering you the code from the Java challengers you can get on the description of this video. There's a link, and then you can just access this link, and then you're gonna get the code from the challengers, okay? And as always, if you like the video, please give a like and get subscribed, because on that way, you're gonna be helping me out to provide even better videos for you, and you're gonna be helping me out to making you really master the Java language and produce even better code on your applications. Okay, so that's it. See you the next time.